Give me 1 second. Let me put the guys for yeah. Let's start the class and let me share the screen. It should go fine. Okay. 1 second. Let me go back. So till yesterday, we tried to complete this part of the course, which were related to the design rules and all sorts of thing. Okay, 1 second. Let me put this somewhere in the top actually. Okay, and let me put it somewhere. Let it be in the top only. Okay, so I did it up till at this level. We actually did it completed at this level. This one. Okay, so we completed everything up till the design rules and everything we completed. Okay, so we entered the MOSFET. These design rules where N plus and P plus regions are formed into two steps, active and N select. We understood these things. Then we came and the gate overhang thing actually, how the gate area get overlap. So what are the minimum DRC rules? So we up till here we completed. So can you guys confirm me that is it okay for you guys to move forward or any doubts is there? Hello.
No, sir, you can move on.
For others, Kalyani, Nilani, Nanda, Akila is not here. What about you, Hiranmai? Can you able to get the things after last class? Hi, Hiranmai. Okay, okay, okay. Okay. Kalyani, Nilani, Nanda, what about you all?
I go through the recordings.
Okay, okay, okay. Yeah, Nanda, you, Nilani. Hello. Nilani, Nanda.
No doubts now, sir. Later I'll let you know, sir. If I get anything, I'll text.
Okay, okay, okay. From here, we will be using etching option. So what is etching? We will be try to understand the etching concept because we till that time we are only understanding etching like wet etching, dry etching, but let bit very small concept of etching we are knowing that we are using the term etching that after every lithography process we are just putting etching. Etching is a chemical. It is to etch out the wash out those unwanted areas. So now we will go into depth of etching. We'll understand what are the types of etching. So we'll go in each of the topic like etching, what is then will CVD process, then ion implantation. So everything we will be going into depth. Okay. So this is the etching process. In etching process, we will be covering what is etching, steps preceding etching in IC fabrication. What are the steps of etching? Types of etching, simple idea of wet etching, like what two types of type of etching, then in which a wet etching is there, the simple idea, then plasma etching, then what is plasma, like what is plasma and what is plasma etching, anisotropic and selectivity, advantage of plasma etching over wet etching. We will be working on these all topics. Okay, let me come here and let's put this one back. And we what is itching? Can anyone tell me what is itching? I have already told this discuss this topic, a brief definition. Can anyone tell me? Hello. What is etching? Can anyone tell me? Kalyani, Nilani, Nanda, Ganesh, then Hiranmai. Can anyone tell me what is etching? Hello.
Removing that chemical layer, we can
Like which layer? Yeah, which layer?
that
No, when someone asks you etching, you have to tell after the photolithography process, the photoresist material which is left over in the surface of the wafer, which was not exposed under the light, UV light or the lithography light, that part is need to be etched out. So that is what we do in the process of etching. So the extra photoresist material which is not under the not exposed under the light is etched out, so that is called etching actually. So you have to tell this definition. If a simple definition is asked, you have to tell simply removing unwanted material from the surface to form a required pattern. This is also you can tell, or you can tell in a bit more explanatory form. Both you can tell. Okay, so if you see here, so this is a PR, this is photoresist material. This is a oxide layer. Okay. So now etching has been done. But due to what? Because the photoresist material, this photoresist material, wherever the photoresist material is over the oxide layer, you when the light will come, suppose, let me put one color here. Let me tell you, if whenever the light will come, suppose when the light is coming from the top, actually the light is coming, like this light will come here, 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 here. What will happen? Light will be falling on these areas also, okay? But due to these areas are covered with this photoresist material, the light will only be able to penetrate this photoresist material and affect the oxide, because that is only the use of the photoresist material. Wherever photoresist material is not available, this cutout region, you can see it is not available, here the light will pass and affect the oxide layer. Okay, here it will affect the oxide layer. Now this oxide layer is affected. Now in the etching process, if you go and see, the etching process will be done. This wherever the it is soft material, it has become now soft. When the light falls, this area becomes soft. This soft area, now what we will do, what will it will do, it will remove this soft area, because due to light falling, this area has become soft completely. Okay, this area has become soft actually. Pali. So this area, whatever this area has, means this area has become soft due to the falling of the light over this area. Now when etching will be done, this area will get removed, wash out. So that is how the use of the etching. Then again, one other process will be there of the etching, which will remove this photoresist material. This is the photoresist material. Okay. So this is how the etching process is done. Okay. Let me write here. You sorry, light. Okay. So this is how etching process is done in this step. Now comes to the steps preceding etching in fabrication. First, step one, I have already told substrate will be there in the top of the. So, can you guys tell me that are you able to hear any background sound, like any loudspeaker sound kind of thing? Can you hear it? Please tell me this one, because due to Durga Puja, all our area is like populated with lots of sound. Please tell me, are you able to hear it or not?
no, sir, clear.
So no background sound coming, right?
Yes, yes.
Yeah, that's fine. That's fine, because I can hear the sound. It should not be inside the recording, because it will be very disturbing then later. So steps preceding in IC fabrication is, first step in the substrate oxide layer will be poured over that one, okay, using the CVD, the silicon dioxide, okay, SiO2 material, that's the oxide. On the top of that one, when SiO2 is over the substrate, they will put the photoresist material. They'll put a photoresist material on top of this guy, okay. Then a mask will be put here in between, how it has been, see, mask is there, and UV light is being passed from here. See, UV light is passing from this area. UV light, you can see it is passing from this area, due to which what happened, the area which is actually under the mask, the area which, see, normally photoresist material, if I have told, I think might have told the opposite one. So this side become hardened and this become soft. No, actually, sorry. The side become hard due to the light falling. The middle one becomes soft. Normally, photoresist material is soft in nature only. Okay. So what I was, because I got confused related to the other process. It is creating actually the gate connection. So that I got confused. Sorry for that one. So when the UV, so first step over the wafer, SiO2 will be available, which is the oxide layer. Then in second, over the SiO2 layer, a photoresist coating will be present. Okay. Now, after this one, the mask will be kept on the top of that one from where the light will pass. Okay, so from where light will not pass, actually the light doesn't pass from that area particularly, so vice versa it is done. Okay, so light, it will be the mask will be given on the top of that one, then the light will pass and fall over the photoresist material. Wherever the mask is there, the light will not pass that area particularly, and the other area, due to the falling of the light, will become hard now. It will become hard now, actually. Okay, now what will happen, so there are two kind of masks. One is normal mask, in which, suppose this area P, this area need to be fabricated. Okay, so this area will be blocked. This area will be blocked, actually, and from the other part light will start falling, due to which what will happen, the oxide will get hardened as it is in this image. Other one kind of mask is there, which is called inverted mask, in which this part will be cut out. If the light falls from this area, the light will pass from this area, and the other part, what will happen, other part will be, light will not pass, in which what will happen, the area where the light is particularly falling, this part will become hard now, and other parts will become soft. It is inverted mask. Then up in this process, what happen? A planarization after the etching happens. Okay, because what will happen? The etching will be there. So this part is, the sides are now softened. The sides are soft, and in this part, if you see, the middle part, which is the cutout and is not available, which is here, it is opaque, the light cannot pass, this will become soft. Now what will happen, in this one, etching can be done. When etching is done, that soft part, which is the soft part where the light didn't fall, and the hard part where the light fall, the soft part, due to the etching, it will get removed, and this kind of shape will come out. Okay, but in the inverted one, what will happen, when the light will fall, and this part will become hard. Okay, and the other sides will become soft, and then when the etching material will be there, the soft side part will go outside this one. Okay, and the below this part will be remain as it is. And then what they will do, they will do a planarization technique. They will do the planarization technique at this particular area only, but in this one, the overall area will be planarized, but in one particular, this area will be planarized, which will lead to this kind of, at last both will give this kind of shape only. Both process will get this kind of shape only. Okay, this kind of shape only you will get, but the process can be changed in time to time, depends upon the company, what machineries they have. Two type of mask, one mask is this one, in which the suppose the anvil is getting fabricated, this will be opaque. From here, light cannot pass. And one will be this kind of mask in which you will see now light can pass, in which light can pass. This area will be opaque. These areas will be opaque actually. These areas will be opaque. From this part, light can pass. Wherever the cutout is there, the light will pass actually. Okay. The light will pass, and in this one, light will not pass from this area. So both will give the same design only, but the technique is bit different. So majorly in the industry, this technique is only used because it is low cost. This is low cost because in this one, what happened? This part will become soft and other parts will become hard because the light is not passing because this part is opaque. In this one, chemical is only sufficient to remove this part. It will remove this part and with the chemical only. But in this part, what will happen? They need a extra planarization apart from the etching chemicals. This due to which the cost of the fabrication gets higher. So very rare technology in very like every industry use, but with very rare technology use this process actually. But you should be knowing both the process. So one is normal mask, one is inverted mask. Okay. So up till it is clear. So after then this etching will be done and the soft part it will remove out. Okay. So you can tell both the process in the interview, but try to be focused on this one because interviewer will be expecting you to tell this process. Okay. But only you need to do here is you have to tell them by you can they might tell you please draw and show us how the things happen. So then what you have to do, how the etching process happen, then you have to tell them, sir, so this is our substrate. Uh, so use this format, okay. Break the screen, divide it in 4 parts, make it step 1, in which substrate, so P sub. Here what we will do, here in P sub, oxide is not will be there. Okay, with P sub, oxide will be there here. Okay, just type here oxide or SiO2, SiO2 or SiO2, O2. Okay, then in the second step do P sub. Okay, in the second step put over the oxide a photoresist material. Okay, just make this kind of structure you can make here. Okay, me write here photoresist, and this should be oxide. Now in this one, what you will do? 1 second. 1 second. Okay. Now in this one, what you will do? You will be putting this oxide again. Then again this photoresist material on top of this one. Okay, right here just PR photoresist oxide OXID oxide, and this should be P sub. Okay, P sub. What have you do? You will be putting a mask like this. Just put a mask like this on top of this one. Okay, mask right here, MASK mask, and from the top just draw UV lights passing like it says UV light. Okay. Now tell them when the UV light fall, this mask will be block the part where the mask is available. It will block the UV lights, and this parts will get the UV light. Due to what will happen, this area will become soft. Okay, and this area will become hard. Okay, tell them like this. Okay, after that one we will be doing the etching in which chemical etchants will be used. Either it will be dry etching or wet etching, that will be discussed later. So you just tell them etching will be there, either dry or wet process will be taken care. In this one, you will be seeing the oxide layer is like this now, because that due to the soft part, and on top of that one, the PR is there, which is the photoresist material. oxide, and this is the PR. Okay. Now, if you see, the mask has been, due to mask there, light didn't fall this area, it becomes soft, and etching chemical removed it out, and it become this cutout came across this one. Okay. Try to explain this process only. If you go with the negative inverted process, this inverted one, if you go, the same will be here. The same will come across here. Up till here, it will be same. But in this one, what will happen? The mask design will change. Let me show you how it will become. It will become like this somehow. It will become like this. But let me tell it to you. 1 second. In this one, what will happen? The mask suppose is like this. Okay. In this one, this part will allow the light. Actually, this part will allow the light. This part will allow the light here. Okay. If this part allows the light and this part doesn't allow the light, what will happen in the next step? This part will become hard now. This part will become hard now, and this part will become soft. Okay. This part will become soft here now. Okay. Now what they will do, after going to this step, after going to this step, you will be adding one more step here, in which this part will be planarized properly before etching is done. Before etching is done, they will first planarize this area, because I want this part to, because it's hard now, this will be planarized with a planarizing machine. It will be planarized this area, but because this area is very precise and planarizing a very small area is difficult, that's why the cost increases. It will planarize this area, this hard area. It will planarize actually. Okay. It will planarize this hard area, due to which what will happen? Due to which what will happen? Let me show you. Let me show you what will here. It will be creating this kind of shape, because it will be planarized, removed. In this one, etching was done. It will remove this part, and this cutout will come. Now, very soften due to this one. Okay. Now this one will be stripped off using the etching, the etchant, by while protecting this oxide layer, because in this step, while putting the PR, the photoresist material, over the oxide, a insulated material is put, so that when the etching happen, it doesn't remove that oxide layer. Okay. That is the reason why they put that insulated material should be there. A IN, sorry, INSU, a insulated material should be there in this one. Then the etching will happen, and it will remove this photoresist particularly, not the oxide. And this shape will finally come in both the cases. Okay. So this is one process of etching, and that is one process of etching. Generally, if you see, who's that? Okay. Generally, if you see in the industry, this process is used. What I just told in the first step, this process will be used. Try to tell this process. If you tell this process, if the interviewer know this process, then he will able to agree with you. But majorly, everyone will knowing this process only. Okay. Till today, I was teaching you over this process. Only the thing is that everything is common between them, but only one step will be missing in both of them, is one planarization technique. Both will planarization will be there for each and every cases, but in which one an extra planarization step will be there for each of the steps, when the fabrication will be done using this method, inverted one. So try to explain this one in the interview. Okay. So this cutout will be there, how I explained you just now. Simply follow that step. Draw the four boxes, in which first draw this one, then draw this one, then draw this one, in which the middle one should be soft. Okay. Not the side one. Middle one should be soft, because due to the mask, it should be hard, and then etching will be done, it will get removed. Okay, and your final shape will come. Okay, so is it now understandable to you, or everyone got able to understand? Hello, hello.
Yes, Subhashish.
Other guys, please tell everyone able to understand and not. Others, please tell.
Yes, sir.
Okay. Hi, Rupali, Akila, you able to understand my? Akila, you
Yes, sir.
joined after a long time.
So due to
Are you
network
watching?
issue, I am unable to join. Sir.
Okay, okay, Akila, no
I go
issue.
through recording, sir.
Okay, okay, okay. Yeah, Rupali, you joined after a long time. So are you watching the videos, recorded sessions? Okay, so now types of etching. So how many types of etching are there? There are two types of etching. One is wet etching and other is dry etching. Dry etching is also called as plasma etching. Okay, so in two types of etching, wet etching is done by liquid chemicals. Generally, this process is cost effective. This is high cost. Okay, so in the wet etching is done by liquid chemicals. So and unmasked areas. So the area which were unmasked. See, these areas are these hard areas are unmasked. Okay, so these unmasked areas are etched away by the chemical reaction, oxidation and reduction process. Okay, so unmasked area, remember this hard area which are not exposed under the mask, the light falls on that part. Okay, so those area will be etched out using the liquid chemicals. Okay, so this is how the etching this fabrication process happens. Okay, I will be sharing one YouTube video. I came across that one. I will be sharing that. It will be very good if you see that video. It's very useful video to which will give you a overview how I cannot bring a fabrication plant here for you, but I will be trying to make show you a fabrication semiconductor fabrication model, how the model looks like inside that one, a working model. We are working on that one. So after successful that one testing, I will able to show it to you. Okay, in the meantime, have a look over the, it will not, the model will not replicate the exact what is inside the fabrication plant, but 90% it will replicate what going on, what's going on inside that plant. Okay, so now come to this step in which I will be showing a video which will be a live demonstration of a fabrication, what happens inside the fabrication, like someone made it actually. That will be if you see that video in your spare time. So this etching, in wet etching, this is done using the liquid chemical. Then comes the plasma etching, what the dry etching. Etching is done exposing the material into a bombardment of iron in the plasma. This is bit costlier in compared to others, but this is much more effective, dry etching. So etching is done exposing the material, which will expose this particular thing, wafer, inside a bombardment of iron, where the ions will get bombarded over that one uh, in the plasma chamber, and it will do the dry etching. Okay, so these are two types of, if anyone asks you what are two types of etching, tell them these are the two types of etching: wet etching, dry etching. Wet etching is done with chemicals, each away, it each out the areas where where the area, the unmasked areas, it will etch out with a chemical reaction. And in dry etching, plasma, which is called plasma etching also, it will the wafer will be put in a plasma chamber in which the bombarded iron will be etching out the whole areas which is unmasked. Okay, now simply comes here the simple idea of wet etching. So etchant, so KOH, HF, BF6, BCl3. These are the chemicals used for the etching process, for wet etching process. Okay, so these are the chemicals used for the etching process. KOF. Remember, if I ask you what are the chemicals used in the etching process, you tell KOF, HF, BF63, sorry, BF6, BCl3. Okay, you just need to tell the, you have to remember this for this chemicals: KOH, HF, BF6, BCl3, in which this HF, hydrofluoric acid. Why this red is not coming properly? Okay, this, in which this HF is used mostly across the industry, hydrofluoric acid. If you see this chemical reaction, this is the silicon dioxide material, okay, SiO2, in which six HF, six atoms of HF will be used on this one, six hydrogen and F, hydrofluoric acid. So six HF will be used here. Okay, so after that one, which will be generate H2SiF6 material. See the liquid, it is dipped into, this is the etching chamber. This is the etching chamber. Etching chamber. This is the etching chamber in which wafer has been dipped out. Okay, so this is the wafer. This is the wafer. Okay, in which the wafer has been dipped here. So these are the chemicals. These are the chemicals. So wafer have been put here, in which what happens now? The liquid is getting reacted to that particular part which was not under the mask actually. Okay, which was not under the sorry, which was under the mask actually, and became softened. So if you see the cutout thing, that part is, this part was inside, so this part was inside that area, inside the mask. This part was inside the mask actually, and it became soft. This area became soft actually. Okay, and this area became hard. These areas became hard, properly hard. And due to what happened, the etching now took care of the soft area, and it is reacting. While reaction happens, this formula comes out. This formula comes out when the etching actually happens. After the etching is done process, this formula comes out actually, if you see, which is SiO2 reacts with 6HF. This is the HF chemical. So this is the HF. Okay, this is the HF chemical actually. It will react with this one, so which will generate H2SiF6 plus 2H2O. Okay, after that you will see this cutout has came across this one. Okay, so this is the how wet etching process is done actually. Okay, then comes the dry etching, which is the plasma etching. Faster and easier way. Both chemicals and ionic species play the role actually here. If you see in this one, let me enlarge this diagram a bit. It should be okay for you to get. Okay, one second please, let me put this one somewhere here. Okay, that will be good. Okay, so if you see in this one, you will able to see. Okay, I think that diagram is not coming across this one. Now it should be fine. Okay. Now, if you see in this one, faster dry etching is faster and easier. Both chemicals and ionic species play the role. In which what happened? This is the plasma chamber. If you see here, the gas inlet ArCF4O2. These are the gases used in the plasma chamber purpose. Okay, you need to see this one. Then a grounded electrical supplies is given there. Okay, so a supply is there, anode and cathode is available in this chamber. Then a gas outlet pump is also there. Okay, then a RF generator and matching network. So this is the connection of that whole plasma chamber, how the plasma process takes care. Okay, so this is the, you can draw the diagram also if the interview asks you. So this is the matching network and the RF generator. Okay, so this will be inside the plasma network with the ground, and here the gas inlet will be there and the gas outlet pump. Here, which two electrodes will be there. See, two electrodes on top and bottom, and between the plasma is there. Plasma sheets are there. In this one, these are the devices are poured inside this one. Okay, so the device is placed inside this one, in which what happens? The bombardment ion takes care of the soft part actually, and it removes that one, and that how this cutout like structure, this cutout like structure comes out. Okay, so this is the process of the dry etching also. So this is how actually dry etching. So if anyone asks you how the dry etching happens, you can tell them with the in the wet etching we use KOH, HF, BF6 and SBCl3, and this formula is generated. Okay, and in this you can draw this diagram to show them how this process happens. And the dry etching, so if the plasma etching, you can tell them that this is the diagram, this is how the plasma etching work, in which the devices are placed at this level. These are the devices were placed at this level, and this is the plasma sheets where the bombardment ion happens here. The ion get bombarded over these devices, and the soft part removes eats out, and then there's a shape, this kind of shape comes out here. This kind of shapes actually comes out, in which this kind of shape actually comes out in this one. Okay, from out of this one. So this is how the plasma etching actually happens. Now let discuss what is plasma actually. Plasma is the fourth state of matter. So solid, liquid, gas, then comes plasma. So there are other states of matter also, which is like BEC, Bose-Einstein condensate. So 6, 7, 8. I think there are roughly 21 or 20 states of matter. But those are actually experimental concept which are being done. So in which, if I'm not wrong, I think 20 or 21 is available. Might be wrong also, because as I know there are many number of states of matter, but generally 4 states are the basic states of matter, in which 3 are the majority part. So so solid, liquid, and gas. Those 3 are the basic states of matter. Plasma is the fourth state of matter. Okay, in which the plasma state of matter, which consists free electron and cations. Okay, it is a state of matter which consists free electrons and the cations. Okay, plasma looks similar to the gas. Plasma is also called an ionized gas. Okay, so if you see, this is a plasma, this is a gas. Plasma it bit dense compared to the gas. It compared to the gas, plasma it be dense. So this is the description of the plasma. I think no interviewer will ask you about plasma. So it's a class 12th question. You guys will be knowing this. So I do not need to explain this in more depth. What is plasma? This is just much more thing to explain of the plasma. Okay. Now, if we come to the next slide, in plasma, if you see if in plasma high number of electron does not move around its orbit. Okay. Plasma is created when gas is either exposed to high temperature or high voltage. You have to tell how the plasma is created. If you see this diagram, these gases ArCF4O2, these either one of the gases will be poured inside this chamber, in which a RF power input will be, because high power RF is the radio frequency, the highest form of the power which is being used inside this one. This is the highest power which is taken. Okay, so you might have been read electromagnetic, in which Smith chart was there. This kind of chart was there. You might have all remembered this chart. If I am not wrong, I think this chart looks like this, some kind of. I have also forgot the chart thing actually. I have, so might be a diagram is wrong. So the chart somehow looks like this only, this kind of thing only, I think. like this, I think it looks. I think like this, somehow it looks actually. Okay, somehow it looks like this. So I might be also wrong. So don't go with the Smith chart. So this RF comes under those things only. Okay. This antenna design, the guys who are responsible for the antenna design, they use this RF thing. RF layout is also there in the analog layout part only, but same techniques are used, but the device which you use here 1 volt or 1.3 volt or 2 volt, in that one the device which you use that has a higher number of voltage, that voltage. Okay, so that is the reason that the RF thing is used in this one. If you see, plasma is created either when it is exposed to high temperature, okay, or with the high voltage. So here it is using, not using the high temperature, it is using the high voltage. That is the reason it is being created. Okay, so plasma, this is how the plasma is being created with the gas. When these gas when these gases are come across this high RF power, it creates the plasma actually. Okay, this is how plasma is being created. Due to these free electrons and cations, plasma easily conducts electricity and also produce magnetic fields. Nature also produce plasma by mean of fire and lightning. So if you've seen this one, you might be very familiar with these diagrams, images, and you might be knowing what is plasma is created, and nature also creates plasma, which is like fire in a form of fire on a lightning thunder. Okay, so these are the, and due to these free electrons and cations, plasma easily conducts electricity and also produce the magnetic field. So if you see, earlier it was there plasma TV from Samsung and LG, it was supposed. So now this plasma TV, I think, has been stopped in the industry due to the manufacturing cost. So no one was purchasing, the costs were too high. In that part, LED TV is being used, light emitting diodes. So earlier those kinds of things were there. Okay, we will be come across the those kind of fabrication techniques also, in which LED fabrication. So this is a CMOS fabrication, which is what I can say MOSFET fabrication. We will come across that LED fabrication also. Then, excuse me, LED fabrication I will be teaching also. So fabrication is bit longer it will take, because it's a very depth concept is there. Okay, so LED fabrication will be there. Diode PN junction will be there, in which diodes and the BJT will be there. Then one topic will come you there, which is called CMOS, where the silicon on insulator or the FDSOI both will be there for the fabrication. FinFET will be there, and last but not least, one other will be there, that is called display semiconductor, the display fabrication, how the display is being made. That is also a very important part of the fabrication. You should be knowing this thing. Okay, so that I will be teaching. So this including this fabrication thing, we will be able to complete this fabrication in the month of this October. I think it will take, so I think more 10-12 classes will be required for the fabrication steps. Okay, so it is required actually, and after that one we will be going to some other steps, the other side, other what I can say, there's other topics, which are, those topics are small topic. Majority big topic is this fabrication thing only, whether it is CMOS or FinFET and other fabrication. After that one, when we will go to the actual analog layout concepts, those concepts will be one class or a half class, each topics will take care. Okay, in that one, so some will be bit bigger, a majority will be smaller. That thing we will be studying and immediately implementing. While implementing only, we will be studying those things. Okay, we'll be studying those things by implementing them, and we'll make small projects. In that one, you will get to know all of it. We cannot make a small project for the fabrication due to the um, cost involvement of the fabrication. So we cannot do this one. So we can only just study via of the PPT thing only, we can study this one. Okay, So we can study this one with the PPT thing only. So after that one, this fabrication step, I will try to complete this fabrication before the October, so that we can start this fabrication thing, the other concept in as early as possible, because the tool familiarization, which was actually that basic tool familiarization, it took roughly a month. Actually, it was not supposed to took a month. I think it was only for a week class, but many of were unable to catch up that thing. So we did multiple blocks, multiple gates we designed, and it took a bit more of time for us. So we have to cover those times. So fabrication will take time for sure, because it's a very big topic and everything to be explained. After this one, after this one, we will be going to each of the topics, and then we will be covering those things. Okay. Or one thing other, I will be updating on that one. So we will be proceeding to those concepts. So what I was thinking, I can just complete the fabrication with MOSFET as well as the FinFET. Both fabrication I complete it first, because your interviews will be starting on the job assistance will be starting from the month of November. So you guys need to explain those concepts also. So I was thinking to put these other parts of the fabrication like FDSOI, all those things at last. Before that one, other concepts I will be taking care, because you need to explain those concepts. Okay, that would be great. Or one thing you can do, you can give some extra time so that we can take some more one hour someday to cover up those concepts, because those concepts will not be in very much depth, like semiconductor fabrication or LED fabrication. It will be, I think, like one class will be taking for each of the topics. FDSOI and PN junction will take bit time. I think 2-3 class each it will take, but one class are fine for the. I will update you on that one. Okay, one class maximum it will take, and it will be covered up. And the whole analog layout concept itself will take a month to cover up those concepts. That will be fine. That's I already planned, and that whole thing will be implemented parallelly. It will done. So theory will be done immediately. We will implement it. So parallelly we will be doing those things, because those things we need to be do parallelly. Because otherwise, if I tell you theory and then I go to the layout, you won't be able to implement those things only. So those things need to be done parallelly itself only. Okay. So after this one, due to increase in the free electrons, so okay, so we completed this topic. So nature also produce plasma by means of fire and lightning also. Okay. Now let's come to the below part. What happens inside a plasma? Actually, if you see, dissociation, ionization, dissociative ionization, excitation, recombination, this all process happens inside the plasma chamber actually. Okay, this all thing happens inside the plasma chamber, which dissociation, CF4 plus E minus, these are the formulas. You do not need to remember this. What happens inside plasma? You have to just remember the dissociation, ionization, dissociative ionization, excitation, and recombination. I'm not going to in depth of this one. These are all the 4 steps happen. So if you want to know depth more, you can try to understand this formula in depth, but it's not required for you to understand this formula, because you are not working on creation of the plasma. This plasma chamber will be inside there. You just need to know what are the steps happening to that plasma, what happens there. Okay, you don't need to know all this formula related things. It's not required. Might some asks you the formula, but the formula will be maximum up till this etching one. This formula is important. You need to remember this one, because sometime interviewer asks what is the formula happens inside the etching. What will be there if SiO2 is reacted to which HF? Or try using this one HF. What will the formula will come from? Remember this one. If you don't remember the plasma one, nothing will happen. Okay. Now comes the 1 second. 1 second. Yes, so physical etching inside the plasma. Okay, etching species are like are ions like CF3 plus or AR plus. okay, which removes material by ion bombardment. Okay, so CF3 plus or ion or AR plus, okay, are which removes material by ion bombardment. So this material, which is a softened part, it will get removed in the ion bombardment with these kinds of ions. Okay, ions etching is much more directional, anisotropic due to directional acceleration of ions by high E field, electrical fields. Okay, so these are the ion species, and it is bombarding at this part. Okay, due to which what happened, this part get etched out. Okay, so this is also, and this ion etching is much more anisotropic in nature, or or more directional due to the directional acceleration. The properness should be there, and anisotropic, this technique is called anisotropic part. Okay, so this is what happens with the ion with CF3 plus and AR plus actually. Okay, now if you come to the what is anisotropic, okay, etchant cannot distinguishes between vertical or horizontal dimensions. Etchant cannot distinguish between horizontal and vertical. What is anisotropic? You need to know. So it cannot decide what is vertical, which is horizontal dimension, or horizontal dimensions or isotropic. Okay, anisotropic is equal to 1 minus dH by dV. There's a formula, simple. Wet etching is isotropic and dry etching is anisotropic. So you have to remember this. Wet etching is isotropic and dry etching is anisotropic. It means etching cannot distinguish between vertical and horizontal. Okay, horizontal because wet etching happens in the horizontal direction. Okay, and the anisotropic, which is this dry etching, it happens in the vertical direction. Okay, it happens in the vertical direction. If you see here, it happens in the vertical direction. Okay, this direction it happens in this direction. And this wet etching, which is isotropic etching, it happens in horizontal direction. It will the chemical will come, the ions will come, strike this part, and it will remove this part, and it will go. This is how it happens, and it directly strikes this one. Okay, so this is how the horizontal and vertical issue. You have to remember, wet etching is isotropic and dry etching is anisotropic. Means wet etching happens in horizontal direction, whereas dry etching happens in anisotropic form, which is in a vertical dimension. You need to remember this. Okay, so this is what anisotropic means actually. Okay, then comes the selectivity. Etchant should distinguish between SiO2 and Si wafer. Etchant should distinguish between the SiO2. What is SiO2? This is the SiO2, and this is the silicon wafer. Okay, or you can see the oxide, you can see also the oxide, which is the wafer. Wet etching is selective than dry etching. Etchant should distinguish. Okay, so etching is selective, because the selective one, it can distinguish between that one. Okay, which one is Si, which one is SiO2. Okay, dry etching cannot do that thing. Dry etching, that's why much more cost effective. It's not cost, it's a good, it's a much more efficient way, but it is much more expensive. Sorry, expensive also. Okay, so SiO2 and Si wafer, it should distinguish, etchant should distinguish. So wet etching much more selective in nature in compared to this one. Okay. Now, if you go after this selectivity is done, now if you go to the advantage of plasma etching over wet etching, okay, eliminate what is the advantages? Cost wise different, but advantages these are. So eliminates handling of dangerous acids and solvents. In wet etching, acids are used. In this one, acids are not used, dangerous acids. Use small amounts of chemical, because plasma, because little amount of chemical, if it is heated, that plasma thing, that gases, it will be converted to plasma, and that can be used. So small amount of chemical. Anisotropic each profiles. Okay, anisotropic each profile means it happens in vertical. Vertical it happens actually. Okay. Then high resolution and cleanliness. It is very much high resolution. It can be done at very lower. So dry only is used in the industry, but that's the reason the overall when it goes to the lower node resolution needs higher. That's why the designing of the lower node cost increases. So high resolution and cleanliness is there, less undercutting and better process control is there. So undercutting is less and better process control is there. Okay, so these are the advantages of plasma etching or the dry etching over the wet etching. Let me write here the dry etching also. Okay, dry etching over the wet etching. So you should be knowing this one, this advantages. You should be familiar with what are the advantages of plasma etching over the wet etching. Okay. So this is how the etching overall etching techniques happen. So what etching, how etching is done, what are the types of etching, which etching is much more preferred over that etching, how the wet etching and dry etching different from each other, how wet etching chemicals are reacted, how dry etching plasma actually react with each other. When the dry etching is done, it is done in a vertical way, which is anisotropic in nature. When wet etching is done, it is done in horizontal way, which is isotropic in nature. These are all the concepts of the etching, how this process is followed, and then this kind of things is done to remove that particular soft mask, soft part which was not exposed under the light. Remove this part. This is the overall etching process happens. Okay, so this is the etching process actually. This is overview of the overall depth concept of the etching process. Okay, this is up till here only etching process is there. Okay, now if you have any question you can ask me. Hello, if you have any question you can ask me now. Hello, Ganesh, Nilani, Nanda, Hiranmay, Rupali, Akila. Any questions? Are you able to get the etching concept? Is the etching concept clear to you?
No questions right now, sir. It is clear. We need to go through the slides and video again, sir.
Yeah, of course you need to. So everything is new to you, so you have to remember this and to get all these concepts. You have to watch those videos again and again. So in a 1 hour, if it is easy to understand the whole etching, then there would be no doubt across the semiconductor industry only.
So can you share the PPT also?
Yeah, I will be sharing the PPT because this PPT need to be bit updated. Okay, that's the reason why I didn't share it. After the completion of the CMOS fabrication, I will share it to you.
Okay.
So if I share you now, many things are not updated in this one. Okay, that is
Actually,
a yeah.
half of the part completed, na sir.
So that much you want?
Yes, sir.
So then what I will do, up till the etching, I will be sharing the PPT. That's fine.
Okay, sir. Oh, yes, sir.
I will be writing in that one, starting from the semiconductor fabrication up till the etching concept. Okay.
Yes, sir.
That I will be writing in that one. I will be dividing it will better. I will be dividing that one. I will sharing you that PPT, that half part of the PPT. Then half part I will share after explaining all those things. Okay.
Okay, sir. Thank you.
Okay. Akila. So okay. So I think in chat some things are there. Okay. Hiranmai. Yeah, Nilani, you're asking something? Yes, Nilani, I will be sharing those. Could you please share the previous slides PPT? Yeah, previous slides PPT, that only I told to Akila, na? Up till the etching, till the time of the starting of the fabrication, till etching, I will be sharing the PPT. Till today's class, I will share in the PPT, okay? Give me one day. I will be updating all this because many things are written over this PPT. You can see these things are written. It looks very bad actually. I will be just updating it properly and I will send it to you. Okay. Give me a day. I will send it to you. Okay then everyone. This is this much only for today's class, and we will be meeting again in next class.